Question number 19 says we have a square and it's divided into three outside triangles, and those three outside triangles are going to be of equal area. And we want to find out what the value of x is, so how long that side length of this one triangle is, to give us three equivalent areas based on this configuration. So we need to find the exact value. So first of all, we need to set up an equation for this. So the equality I'm going to set up is this. I'm going to set up that the x squared triangle, so x squared over 2, this triangle in here is going to be equivalent in area to this triangle here, which is going to be, and to get the length of that, this unknown side, we have to take the original length of 6 and minus x. So that little length there is 6 minus x. So we end up with the area of the triangle is 6 times 6 minus x, and that's divided by 2. And then we can solve for the value of x based on that relationship. So solving this then, I'm going to multiply both sides by 2. So I'm going to end up with x squared is equal to 36 minus 6x. And then solving this quadratic equation, I'm going to make it equal to 0. So plus 6x minus 36. And we're going to make that equal to 0. And at this point, I'm just going to plug this into the quadratic formula. So in the quadratic formula, I end up with x is equal to negative 6 plus minus square root of 36. So 6 squared minus 4 times a, which is 1, and times c, which is negative 36. And that's all over 2 times 1, or just 2. And then simplifying this expression, we end up with negative 6 plus minus the square root of, this works out to be 36 minus negative, or plus 144, and so that gives us a value of square root 180, and that's all over 2. And then we can simplify this expression. I'm going to factor out the perfect square out of here. The perfect square factor of 180 is going to be 36. That's the largest perfect square factor. So I end up with negative 6 plus minus 6 and square root 5. So the square root of 36 is going to be 6, and I'm left over with a 5 inside the root, all divided by 2, and that gives us a side length of negative 3 plus minus 3 root 5. Now the value of x can't be negative, so we have to then eliminate the negative version of that, and the side length x is going to be negative 3 plus 3 square root 5. And that's the exact value of that side length, and that's going to be, in this case, meters.